13.8 billion years ago, everything you have ever known, space, time, energy, matter, all of it, emerged from an unimaginable singularity. A single point, smaller than any atom, unfurled to become the vast, sprawling cosmos we see today. It's a concept that is both simple and profoundly baffling. It forces us to ask one of the deepest questions imaginable. What existed before this beginning? Why is there something in our universe instead of an eternal absolute nothing? And why do we, tiny specks of life on a pale blue dot, care so deeply to find the answers? Our journey tonight is not just about the birth of stars and galaxies. It's about the birth of the question, why? For millennia, humanity gazed at the night sky and assumed what we saw was eternal and unchanging. The universe, in our collective imagination, simply was asterisk. This idea, known as the steady-state model, felt intuitive. It was comfortable. But in the early 20th century, a series of revolutionary discoveries began to unravel this timeless tapestry. It started with Albert Einstein, whose equations for general relativity hinted at a dynamic, evolving universe, a possibility that even he initially found unsettling. Then came the observations of an astronomer named Edwin Hubble. Perched atop a mountain, peering through the Hooker telescope, he made a discovery that would forever change our place in the cosmos. He saw that galaxies, these immense islands of stars, were not static. They were all rushing away from us, and the farther away they were, the faster they were receding. The universe wasn't standing still. It was expanding. This was the first concrete clue that if everything is moving apart now, then long ago, everything must have been incredibly close together. Even eternity, it seemed, had a beginning. But the final irrefutable proof came not from looking out, but from listening in. In 1965, two radio astronomers, Arnold Penzias and Robert Wilson, detected a faint, persistent hiss coming from every direction in the sky. It was a cosmic static that they couldn't eliminate. This wasn't equipment malfunction. It was the afterglow of creation itself, the cosmic microwave background radiation, the faint echo of the Big Bang still reverberating across the universe. The steady-state theory was shattered, and in its place stood a new explosive origin story. So, what actually happened in that first infinitesimal moment? To truly grasp it, we need to let go of our everyday understanding of time and space. Picture this, a point of infinite density and temperature, a singularity where all the fundamental forces of nature, gravity, electromagnetism, and the nuclear forces were unified into a single perfect superforce. This wasn't just a dense ball of matter sitting asterisk in asterisk space. It was asterisk all of space, time, and energy compressed into an infinitely small point. Then, in a fraction of a second, something incredible happened. Inflation. The universe expanded exponentially, faster than the speed of light, stretching from the size of a subatomic particle to the size of a grapefruit almost instantaneously. It's a mind-bending idea, but it's the best explanation we have for why the universe is so vast and uniform. Immediately after this explosive growth, the universe began to cool. The unified forces split apart, creating the laws of physics as we know them today. In less than 1 second, the laws of physics, chemistry, and existence itself switched on. As it cooled further, energy began to congeal into matter-first quarks and electrons, which then combined to form protons and neutrons. For the next 380,000 years, the universe was a hot, dense, opaque fog of plasma. Finally, it cooled enough for electrons to be captured by atomic nuclei, forming the first atoms, mostly hydrogen and helium. For the first time, light could travel freely across the cosmos. This is the very light we now detect as the cosmic microwave background. The universe became transparent, and the stage was set for the next act, the slow, patient gathering of these primordial atoms by gravity, forming the first stars, and then the first galaxies. This brings us to the ultimate question. What came before the Big Bang? Here, we leave the realm of observation and enter the world of theoretical physics and profound philosophical speculation. The honest scientific answer is, we don't know. Our laws of physics break down at the singularity. Time and space, as we define them, begin asterisk at asterisk the Big Bang, so the very concept of before might be meaningless. It's like asking what's north of the North Pole, but that hasn't stopped scientists from proposing some fascinating theories. One idea is the quantum foam hypothesis. According to quantum mechanics, even a perfect vacuum, true nothingness, is not empty. It's a bubbling, seething sea of virtual particles winking in and out of existence due to quantum fluctuations. Perhaps our universe is just one of these fluctuations that by pure chance grew to a colossal scale. Then there's the cyclic universe model, which suggests our Big Bang wasn't the first. In this view, the universe undergoes an eternal cycle of expansion and contraction, a Big Bang followed by a big crunch, over and over, like a cosmic breath. We are simply living in one of infinite iterations. Another popular idea is the multiverse. Our universe might be just one bubble in a vast cosmic ocean of other universes, each with potentially different laws of physics, all constantly being born from a larger metaverse. Or perhaps the answer lies in understanding that there was no before. Maybe time itself was born in the Big Bang. Trying to imagine a state without time is perhaps the greatest challenge for the human mind. This deep, almost primal need to understand our origins isn't just a scientific curiosity. It's a fundamental part of our psychology. Our brains are hardwired for causality. We are pattern-seeking machines, and from a very young age, we learn that every effect has a cause. A glass falls because it was pushed. A sound is heard because something made it. The idea of an effect without a cause of a universe appearing from absolute nothingness creates a profound cognitive dissonance. It violates the most basic rule our minds use to make sense of the world. This is why we invent origin stories. Every culture throughout history has had its creation myth, a narrative that provides an answer to the question, where did we come from? These stories give us a sense of order and purpose in a chaotic world. Psychologists also talk about the Zeigarnik effect, our mind's tendency to obsess over incomplete tasks or unresolved questions. The ultimate unresolved question is the origin of everything. This inherent discomfort with nothingness drives us. It fuels our scientific inquiries, our spiritual quests, and our artistic expressions. Our minds evolved to seek meaning. To us, even the universe must have a purpose, because the idea of a random causeless existence can be a terrifying one to confront. But confronting this vastness can also be incredibly healing. When we contemplate the sheer scale of the cosmos, the billions of galaxies, each with billions of stars, we experience a powerful emotion, awe. Awe is not just a feeling of wonder. It's a measurable psychological state. Researchers at institutions like UC Berkeley have found that experiencing awe can actually make us feel less self-important, more connected to others, and more satisfied with our lives. It's a kind of awe therapy. By making our personal worries and anxieties seem small in comparison to the grand cosmic drama, awe provides a profound sense of perspective. The great astronomer Carl Sagan called this the cosmic perspective. He argued it was the ultimate antidote to human arrogance, conflict, and division. When we truly grasp that our planet is just a tiny stage in a vast cosmic arena, our squabbles and our self-importance begin to melt away. We are not just observers of the universe. We are a part of it. We are stardust questioning the stars. The iron in our blood, the calcium in our bones, the carbon in our DNA, every atom in our bodies was forged in the heart of a dying star billions of years ago. We are, quite literally, made of the same stuff as the cosmos. We are its children, trying to understand our parent. And the connection might be even deeper than we imagine. When we look at images of the universe on its largest scales, we see the cosmic web, a breathtakingly intricate network of galactic filaments and clusters stretching across billions of light years. In a striking example of cosmic mirroring, this structure looks remarkably similar to the network of neurons in the human brain. Both the universe and the brain are complex systems that evolve through a delicate dance of chaos and order. They are both information processing networks, one processing the laws of physics, the other processing thought and consciousness. This isn't just a poetic coincidence. The same fundamental laws that sculpted galaxies and ignited stars also govern the chemical reactions that create the electrical impulses in your mind. The universe isn't something out there, separate from you. You are not asterisk and asterisk the universe. You asterisk are asterisk the universe, experiencing itself. The cosmos, through you, has become conscious. You are the vessel through which the universe looks back upon itself in wonder. So, what is the ultimate meaning of the beginning? Perhaps we've been looking at it the wrong way. Maybe the Big Bang wasn't just the birth of matter and energy. Maybe it was the birth of potential, the birth of information, the birth of awareness itself. Perhaps the universe didn't just explode into existence. Perhaps, in that singular moment, it woke up. And for 13.8 billion years, through the slow, patient process of cosmic and biological evolution, that initial spark of potential grew and complexified until it resulted in a mind capable of asking, where did I come from? The story of the Big Bang is not just a story about the distant past. It's the story of where we came from, who we are, and why we are driven to look up at the night sky, searching for the faint, lingering echo of that first magnificent spark. Thank you so much for joining me on this journey through time and space. If you found this exploration as fascinating as I do, please consider liking this video and subscribing to the channel for more deep dives into the mysteries of our universe. Your support makes it all possible. Until next time, keep looking up.